Hi students, welcome to physics classes. Now in the previous class we have discussed about Galileo law of inertia. Previous class we discussed about Galileo's law of inertia. Now by using this Galileo's law of inertia, greatest scientist Newton laid the foundation of mechanics. Foundation of mechanics. In terms of mechanics, he given three laws. He given three laws of motion that go by his name. That are Newton's laws of motion. Newton's laws of motion. Now, what is Galileo's law of inertia? What we discussed. If no external force acts on a body, if no external force acts on a body, the body, if it is at rest, if the body is at rest, it continues to remain in rest. If it is in motion, it continues with uniform motion in a straight line. Uniform motion in a straight line. If the body is at rest, it continues to be at rest. It remains in the state of rest. If the body is in motion, it remains in the state of uniform motion in a straight line. By using this, Newton given his first law. Now what is Newton's first law? Every body continues to be in state of rest or of uniform motion in straight line unless it compelled by an external force. Unless we apply any external force, if the body is at rest, it will be in rest. If the body is moving, it will move in straight line with uniform motion unless we apply any external force. That is Newton's first law. That is Newton's first law. Now, here from this we can say, when the body is in the state of rest or moving with uniform linear motion, we can say that there is no acceleration or zero acceleration. When if the body is at a rest or uniform linear motion, linear means straight line, uniform linear motion, then we can say the body has zero acceleration. The body has zero acceleration. So we can say if the net external force on the body is zero, if net external force on the body is zero, then its acceleration also zero. Net external force is zero. When net external force zero, if the body is at rest or uniform linear motion, the body is in the state of rest or uniform linear motion, we can say net external force acting on it zero. So whenever net external force acting on the body is zero, acceleration also zero. Acceleration can be non-zero if F net is acting on it. If some external force acts on the body, then only it will have non-zero acceleration. Once I can see, if the body is at rest or of uniform linear motion, then we can say the body has zero acceleration. That means if net external force is zero, if the body is at rest or uniform linear motion, means external force is zero. If there is no net external force, then only the body is either at rest or of uniform linear motion. So when the body is in this situation, acceleration is zero. F net is zero, then acceleration also zero. Only when net external force is acting on the body, acceleration is non-zero. If force is there, acceleration is non-zero. If force not there, acceleration is zero. Here we will have two kinds of situations. Now we will see that. First situation. Now for example, if we know that F net equal to 0, if we know net external force is 0, then we can conclude that acceleration on the body is 0. Acceleration on the body is 0. See here what I am saying, net external force acting on the body is 0. If we know that there is no net force acting on the body, so we can conclude that acceleration is 0. Acceleration is 0. Either body acceleration 0 means either the body is at rest or moving with uniform motion in a straight line. Okay. Then once again, if we know net external force is 0, then we can say that acceleration 0. Acceleration 0 means the body is either at rest or moving with uniform motion in straight line. Okay. Second situation, we don't know what are the forces acting on the body. We don't know what are the forces acting on the body. In that case, if the body is not accelerated, if we know body is not accelerated, if we know body is not accelerated, we know that body is not accelerated, we can say that external force is 0. External force is 0. Here one confusion. What is that? Everywhere gravitation is there. Gravity is there everywhere. Gravitational force of gravity. So on every object, gravitational force is acting, no? On every object, gravitational force is acting. Means if we know the body is not accelerated, we are saying that net external force is 0. This implies this one. But on the body, gravitational force is there. Either the body is at rest or moving. And in some cases, when the body is in motion, some forces are acting on it. What are that? Friction. Frictional force is acting on that. And viscous drag acting on the body. So how can we say? See here, if the body is not accelerated means it is not mean that no force acting on it. I am saying if the body not accelerated, it is not mean that no force acting on it. Forces are acting. Like gravity, frictional force, viscous drag. Like different forces are acting. But they are acting in equal and opposite direction. For example, a book is placed on the table. Now we will take it is at rest. Book is placed on the table, it is at rest. Means when the body is at rest, not accelerated, means F net equal to 0. That means what are the forces acting on the book? Weight of the book acting downwards, means gravitational force on the book acting downward direction. To balance it, this table is applying some force on the book, that is normal reaction R. So two forces are acting here, but they both are equal. Whenever the body is not accelerated means we can't say that there is no force acting on the body. Some forces are acting, but their resultant equal to 0. Their net force equal to 0. Okay. This is about Newton's first law. Thank you for watching. Please subscribe for more updates.